This video is designed to provide you a brief introduction to calculating solution concentrations when you are performing serial dilutions. This table is a modified version of one taken from the Guided Inquiry POGIL workbook for analytical chemistry, the Solutions and Dilutions workbook activity. The areas in gray are the cells that we need to fill out, and there are several that are provided to help us make sure that we are on track to calculate correctly. In this type of table, I do recommend that we calculate values down the columns first as opposed to going across in rows, because when we take a look at the type of math that we need to do, the math is the same for all the cells in column F, and then everything in column G is done the same, and this allows us to focus on one particular problem at a time. Down here, if you want to cut to the chase, is what needs to be done for each column. In column F, we're using M1V1 equals M2V2, and we just need to pay attention to which column or which solution is actually being diluted. Notice here for solution A, we're using our stock solution, which is a nickel solution, in this case nickel nitrate, with a concentration of nickel being 2,000 parts per million. Taking 5 milliliters and diluting it to a final volume of 50 milliliters is a 1 to 10 dilution, so we should expect to see a tenfold dilution, and it is 200 parts per million. To calculate solution B, we are taking the solution concentration from A, notice we want A, and diluting 5 milliliters into 100. So if I were to do that, equals 200 times 5 divided by 100, and we get a 10 ppm solution. If we notice 5 and 10, if we remember our nickels, there are 20 nickels in a dollar, so this should be a 20-fold dilution from the original concentration, and that seems to make sense. For the next cell, we're diluting solution B this time, so I am going to choose this one, times 5 milliliters divided by 5. That's a tenfold dilution, so we're going from 10 to 1 part per million. That seems to make sense. And then lastly, equals solution B, it's this one, times 25 divided by, there we go. Okay, so we have column F. Column G, if we want concentrations, the first thing that we need to do is convert the ppm of nickel nitrate. I'm sorry, we have to convert the ppm of nickel into the parts per million nickel nitrate. And I do that with some stoichiometry here. I don't need to talk through this. You can take a look at the math and see how we get 6226 parts per million nickel nitrate. And we will go ahead and just type that in right here, 6226 times that divided by that. And there we are, 623. Again, this was a tenfold dilution from 2000 to 200, and we do see this is a tenfold dilution, so it seems to be making sense. Then let's go ahead and do the rest. This one is B. Then we also have, oops, B. And the last one is also B. Great. I think that's all correct. Now we've got a couple cells here that we need to fill out, and instead of using parts per million as our unit of concentration, we're using molarity. I'm going to start off with the molarity of nickel, so column I. I'm going to skip column 8 for just a second. Again, in order to get molarity, we need to do some stoichiometry or unit conversion, 2000 ppms, the definition of parts per million, molecular weight, and conversion between liters and milliliters, and we get a concentration 0.03408. And the first one is done for us here. We see it should be a 10-fold dilution, and 0.03 is 10 to the minus 2, 0.003, 10 to the minus 3. We seem to be doing well here. And again, now once we've got that information, we're just going to do our M1V1 equals M2V2. Lastly, to fill out this this table here, or this column here in the table, we note that the relationship between the amount of nickel in nickel nitrate is 1:1. So for every 1 molecule of nickel nitrate, we have 1 ion of nickel. So if I were to squeeze in another stoichiometry in here, we would see that the conversion factor is 1:1. And I'm going to just put in equal signs to each one of these. And there we go. We have our table filled out, and this should have given you an understanding of how to fill out this table if you're performing the POGIL worksheet, or if you were just trying to get some experience in converting parts per million to molar concentrations and crunch through some serial dilution equations.